The real question for AI engineers nowadays is how do you bring the cost for a single conversation from this to this, given that your product is an agent that's sitting between the user and some kind of an open API or Claude API that's hosting the LLM. You're going to be paying for each prompt that the user makes. And obviously you want to reduce that payment because depending on what kind of an LLM you're going to be using, obviously stronger LLMs have bigger context sizes and they also cost more. For example, Claude Opus is going to cost this much for 1K tokens, and as tokens are our currency of LLMs, this is way too much. And not to forget, we also have to pay for the output. Not to mention the fact that bigger context sizes are not even always ideal. We have a problem called lost in the middle where the LLM actually disregards the user prompt if it gets too big, and especially the middle section. So despite all the products that we have in our hand with guardrailing, rate limiting, and batching, engineers are the ones who have to deal with this waste, meaning 50 to 70% of our tokens are actually wasted, and this has to be optimized. Tokens means money, more tokens means lower performance because the LLM has to actually read all of those tokens. And of course, as we learned, it's also less quality. Now, there are three major strategies that you as an AI engineer can use. And that's why you should watch the video till the very end. And we're going to start with the first one, which is simply better prompt engineering. And here are the examples. But what is prompt engineering anyway? Well, it's the fact that we don't have to fine tune the LLM anymore. We're simply not touching it. What we need to work on is actually the user's prompt. For example, you can let your agent decide which LLM it wants to use based on the user's input. For example, for simple tasks, we're going to be using this one. For complex ones, we're going to be using Claude Sonnet. So every time the user gives us a prompt, given that it wants something, it's a task, we're going to classify it either by simple or complex task. As soon as we have it, and by the way, for classification, I'm also going to be using the very simple LLM. As soon as we have the classification, we simply have an if statement that decides if it's a simple one, then use the OpenAPI client, which is the GPT-4o, or if it's a complex task, then we're going to be using Claude Sonnet from Anthropic. Concise prompts should be a no-brainer, but still a lot of engineers are making this mistake by wasting a lot of tokens. Instead, you can opt in for something smaller, very clear, so that the LLM knows what to do just by reading this one sentence. Next, there's a thing called zero-shot prompt and a few-shot prompt. Zero-shot prompt simply gives a prompt to the LLM and, for example, says, classify this as either positive or negative, while a few-shot prompt actually gives some examples before asking something. And why do we need that? Well, few-shot prompts actually reduce the chances of the LLM misinterpreting the instructions, although the one-shot prompt is costing less. And last but not least, you can opt in for a batch prompting. Instead of giving one system prompt and 3 different user prompts, you can simply merge all of that into one prompt and give it to an LLM. And this has been studied and proven that it actually does not reduce the quality as long as you do batch prompting for similar requests. By the way, I was on a hackathon last weekend and I had to build a prototype within 1 day. And while I was searching for a perfect tool that's gonna let me vibe code and build a website, I stumbled upon YouWare. And I was lucky to learn that YouWare, who is the sponsor of today's video, lets you do exactly that by simply vibe coding. Just imagine turning an idea into a working web app, not by writing code, but simply by having a conversation. That's exactly what this platform calls vibe coding. You describe what you want and YouWare generates the project from scratch live in your browser in minutes. One thing I love about it is credit care. If the AI generates something you don't like or you try something experimental that doesn't work out, YouWare literally refines your credits automatically, so you're never afraid to explore or test ideas. And it doesn't stop at just design. With YouBase, YouWare gives you a real backend right out of the box. You get database storage, user login and authentication, file and media storage, and even secure secrets management for things like API keys, all without setting up servers or writing backend code yourself. That means your app isn't just a static prototype, it's a full-stack production-ready application. But the feature that really blew me away while building was CoView. Instead of trying to describe UI issues or bugs with text, you can share your screen and talk to the AI in real time. The AI sees exactly what you're doing, including hover states, transitions, and context, then fixes or adjusts the design for you. It feels like you're sitting next to a human engineer guiding your project. I used YouWare on my hackathon to go from an idea to a live preview of my application. And if you want to experiment with your ideas, as a viewer of my channel, you're gonna get a discount by using the link below. Go check it out and let me know what you think. Now, the next point we're gonna talk about is optimized caching. The first type is gonna be response caching, meaning we have a fast API in between, and if the user makes a prompt, the prompt goes to an LLM responds, and the user gets an answer. What we wanna do though is eliminate this round trip to an LLM and back. For this, if the user asks, for example, what is a pi number, and the next day the user asks the same, we actually want to retrieve this from a cache and not from an LLM. Meaning, if the LLM returns the answer the first time, we're actually going to be using some kind of a database, basically a key value store where we can store this question. Meaning, the next day, if the question comes as what is a pi number, and our question is already stored in the simple text and the answer as well, we're going to be giving this value back to the user instead of contacting the LLM. Now, a cool thing here is though that we can also vectorize this, because now it's going to be semantic caching and not just response caching. Semantic caching means that the question does not have to be what is a pi number. It can also be what does a pi number mean, or what's the meaning of pi number? Meaning these sentences are semantically similar. And by the way, I have a video on vector databases. Go check it out if you want to learn more about this. Semantic caching in LangGraph would look something like this. We're importing our vector store database, and it can also be MongoDB or Redis, by the way. And the first thing we're going to do is do a similarity search on the database. And if the results are found, then we're giving the response. If not, only then we're invoking our LLM with the question of the user. And then, of course, storing it in the database again. And last but very important one is context management. Context management or context engineering means we don't only care about the system prompt or the user prompt, but we care about the whole stack of the things that can go into the context window, meaning the system prompt, user prompt, short-term and long-term memory, the RAG, tools, structured output, and all the guardrails. So all of these things have to be managed before the prompt is gone to an LLM. And by the way, I'm going to be making more videos on prompt engineering as well as context engineering. So make sure to subscribe so that you're a well-equipped AI engineer and don't miss any future videos. The gist of context engineering would be summarizing the patterns, trimming the long old messages from the context, and of course purging any redundant state that's coming from the memory. For example, if the user had this long conversation with our system where they're asking about some questions and then figuring out that never mind, we can forget that. What you can do is actually summarize all of that conversation and then store it in memory and delete the old sentences from the memory. Or if the user supplies a very long error stack into our system with some type error, which we can do again to analyze this, or first to detect this and then make a summary out of that as well, so that we're making sure that we don't save really long error stacks in our database. Lucky for us, tools like LangChain and LangGraph actually have pre-made or predefined classes for exactly that. One of them is conversation summary memory. What it's going to do is it's going to have a rolling memory that automatically summarizes the conversations. Meaning if the user asks multiple things, it's not just going to blatantly save all of that in a database, but instead make a summary as soon as it decides that the window or the memory is getting too long. If you guys learned something new, make sure to like the video and subscribe, and I'm going to see you guys in the next one. Goodbye.